Hey everyone, welcome back. Salman here, episode 4 of our Snowflake Enterprise from Scratch series. Uh, Quick check, if you have been following along on your own trial account, by now you should have 9 databases, 4 domain specific warehouses, and inside those databases, absolutely nothing. Empty schemas, no tables, no views, no stages. Okay, that is the gap we close today. We're going to build the schemas, tables, and views and stages. This is the episode where the platform stops looking like it's nothing and starts looking like a real data warehouse. We create our first table and we do it by the right way with the deliberate table type strategy, a complete object naming convention, and understanding of exactly what Snowflake's time travel and failsafe protect and what they don't. There is a design decision in this episode that has a real cost impact at scale. And most of the Snowflake trial or tutorials never mention it. So let us get into it. Okay. A quick 90-second recap. After 3 episodes, Northwind has 3 databases. Northwind has, 3 environments and 9 databases like this. Broad Dev and UAT, these are the 3 environments, and we have created 9 databases. Okay. Also, we have created 4 warehouses. Correct. 4 warehouses is also created. Create here. Hmm? So we have configured these 4 warehouses in the last episode, and that is the structure. But every schema inside every one of those databases is completely empty. Correct? Today we work in the prod sales table, the sales domain production environment. This is where we will build the pattern that gets replicated across all the domains. By the end of this episode, we will have a customer entity fully modeled, from raw through to mart. Okay, we'll create the infrastructure objects, a stage, and a file format, and we'll use it in the pipeline for the data ingestion in the upcoming episodes. Okay, let me switch back to our presentation. This is how we are going to do it in the hierarchical manner. These are the databases. So we are today we are going to work on the sales table. Okay, prod underscore sales database. And schemas are like raw, stages, curated, and Madeline architecture we are going to follow. These are the objects, table, view, stages, streams, tasks, functions. Okay. Before we create anything, I want this hierarchy locked in your head, because every object you ever create in Snowflake lives somewhere in this tree. And knowing where is the first step to knowing how to create it correctly. At the top, organization, we covered this in episode 2. Sits above accounts managed by org admin. Northwind has one account under one org. Second is account. Our Northwind is trial. Everything we build lives here in the uh, Northwind account. In the databases, we have created 9 databases in the episode 2. Like, so every object belongs to exactly one database, correct? Schemas, the 4 layer inside each databases, and the bottom is like object tables views. The reason I'm showing you this hierarchy is because I want you to feel the three-part address every object has. When you write a fully qualified reference it, okay, when you write a fully qualified reference, it is database, schema, object. Okay. For example, prod underscore sales is the database, curated is the schema, and the dim underscore customer kind of table. For example, you can relate it. Okay. So here is the design decision most tutorials skip. Snowflake has 5 tables type, and choosing the wrong one waste storage or break your recovery strategy. Okay. First of all, permanent table. This is the default table. Uh, while creating the table, we don't need any keyword. For example, you can use create table. Okay. It will automatically create a permanent table, and you get up to 90 days of time travel and 7 days of fail sub feature. Okay. Window. Fail sub window. Use for any table that must survive an accidental drop or a production incident. So all the production table we are going to use permanent table. Second one is transient table. As you know, I have named it as in staging. Here for the transient table, we are not going to get any fail set. Okay. 0 to 1 day of time travel. Same query performance as permanent. Okay. If we accidentally drop it, time travel has expired, it is gone. But this is the key. For intermediate staging data that you can always reload from source, failsafe is pure overhead. You are paying for recovery window on that. So if you had never actually recovered from Snowflake anyway, okay. For the staging data, you can use transient table. Third one is temporary table. This temporary table is like limited to your current session. So once your session is disconnected, it will automatically drop. Okay. It is going to use for debug work or ephemeral pivots with dbt run. And one thing it is like never use it for anything another user or another session needs to see it. Okay. For the debug work, we're going to use temporary tables. Fourth one is external table. SQL inference work file sitting in the S3 or ADLS or GCS, Google Storage, without loading them into Snowflake, useful for querying cold data you don't want to pay Snowflake storage on. Okay, so we are going to query the data which is sitting inside AWS, Google Storage, or Azure Storage. But the performance is significantly slower than the native tables because data isn't in the Snowflake's optimized columnar format. So, do not use it for the high frequency BI queries. And the last one is dynamic table. Uh, Dynamic tables are very interesting thing to know. They are available in the enterprise edition or higher. Materialize, auto refresh, aggregation managed by Snowflake. It is going to replace complex task plus streams pipeline for certain pattern We'll look at these in episode 17 when we cover CDC and pipeline orchestration. Okay, so just keep in mind, like, we are going to cover dynamic table as well. For now, it auto refreshes. Okay, aggregations managed by Snowflake. I think theory is enough now. Let us get into the practical thing. Like, this is the snapshot how we are going to implement it. Okay, raw schema, staging schema, curated and marked. Which table types are there. Okay, it is pretty visible by looking at the PPT itself. And for before we go live and create table, let me cover two infrastructure object that sits upstream of table. One is stages and second one is file formats. A stage is a pointer to a storage location. Okay, it tells Snowflake where to look for files when you run a copy into statement. There are two categories, sorry. Internal stage, which are Snowflake managed storage inside your account. And second one is external stages, which are pointed to cloud storage you own, like S3 or Azure or Google Storage. One on point, the production pattern is external stage pointing to S3. That is what Snowpipe will use in the episode 14. Today we create a named internal stage as the development and testing pattern. So we have somewhere to upload small test files manually. The most important thing about stages, always create named stages, never use a table stage or use a stage for anything that is going to run in production. Named stages are documentable, grantable as RBAC objects, and reusable across multiple copy statements. So file format and all of these things we are going to cover it. Okay. What is file format? Just to give you the small kind of definition. File storage. A named file format. Okay. How Snowflake should pass the files into stages. So we will introduce Snowflake, like what kind of data that is coming into Snowflake with the help of file format. Okay. Now let's get into the actual demo. So I copied these commands into my Snowflake account already. Let us just jump. So we are starting for prod cells. Okay, prod cells database, and building the customer entity from raw through mart. Okay, I want to draw attention to the warehouse before we run anything. So first of all, let me choose the warehouse. Now it is going to use admin warehouse. Now I'm going to use the process database. Okay. I'm going to use the raw schema. Okay. If we can notice here, all of the changes are reflecting automatically. So we're going to create first table, and if you notice the keyword is transient right there in create transient table. If you don't see that keyword, it is permanent table. Explicit is better than implicit. Okay. Second, the metadata column, load underscore id, load underscore ts. Okay. Source file. These three columns go on every raw table in this series. There is not in the source data. We generate them at the load time. They tell you which load run this row came from, when it arrived, and which file it came from. That this is what makes data lineage, okay, trivial to query later. Third one is raw JSON, and the final one is like comment we have, like for what this table we have created. Uh, Raw JSON, like this column type is as a variant. Snowflake's variant type stores semi-structured data like JSON, Avro, or Parquet. The raw landing pattern we use in Northwind. Okay, land the full source record as JSON invariant, then parse the type into staging layer. We as an admin, uh, we get these kinds of deployment files from the data engineers or the architect, but we should also understand like what exactly we are creating. So that's how it is. Okay. If you pay attention, it is better while you perform in your interviews, but not that important. Like they're not going to ask you like, are you created stable format and all of this. Okay. So first table has been created under the prod cells table, a prod cells database, and under raw schema. So let me refresh it. So this is prod cells, and under raw we see one new table, raw underscore customers. Okay. Second thing is like we are going to create the let us wait for some time. Getting confused. Okay. So first thing is like we have created our first object as a raw customer table under the uh, raw schema of prod underscore sales database. Now we're going to create the file format. Okay. So this file format we're going to use it in the data ingestion. So again, the format is like syntax is same. Create file format. Type we need to mention field delimiter, how the data is separated, skip header. So first one is the header line, null if, empty field, trim space, date format, time format. So these are the optional parameters you need to give it while creating the file format. So I'm creating it. Okay, file format has been created. As discussed, we are going to create the staging as well. So for creating stage, you need to mention the file format. Okay, so file format is already created. So we're going to create a like a stage for this database. So while loading the data, we're going to use this file format and this stage. Okay. Now for the staging layer, we're going to switch it to staging schema. We're going to create the table same format, like create table, and you need to provide your columns and comment like for what this table has been created. Now we're going to use the curated schema. Just execute those, okay? Not to worry, because the other operations are like loading the data, creating the CI/CD pipeline, and making this account secure, designing the RBAC. Everything is important for us. Okay, designing this is the part of data engineer's job or architect's job. We just need to execute it as an ad. Okay, so I'm creating all of them. If you get confused, we can have another session on this. Let me know in the comment section. Okay? All good now. Let me refresh. So raw on stage, we have created the tables. File format is also created. And in the staging, one table is there. Okay. So what is under the information schema? So it has like real-time information about our database. Okay, this is something which we are going to deal on day-to-day basis while doing our troubleshooting. The information schema. So table type strategy documented per layer, 4 tables in the prod cells, raw underscore customer. Let me close it. Information schema. Raw underscore customer table, stage underscore customer table. Okay. A dim underscore customer table. Where is that schema? I think one table is missing. So okay. Sorry. So what we locked in today, table type strategy documented per layer, 4 table in product sense. Okay. Let me switch back to okay. 4 tables under prod underscore sales table. This is prod underscore sales table, and the schemas we have created like curated, curated, marked, raw, and staging. Okay. So under each schema we have created few tables. First is it's not showing the object. sorry, I click product underscore finance now. So product underscore sales table. So under curated we have created dim underscore customer table. Under mart we have created dim underscore. Oh, this is again created, I think. Let me remove this. I think I have created using the same. How to delete this table now? Underscore mart. Okay. Drop table command. We can use it. Let me use the full format. Okay. So RPT underscore customer summary, and inside raw we have one more table like raw's customer, and inside stage uh, we have created one stage. So today we are not going to do the PI column level masking or raw level access policies. We are going to cover them in the episode 10, and episode 11 we are going to bring the data from external stage. We're going to load it. Okay. So uh, like streams and tasks, they are also planned in the upcoming episodes. So today we have created like our problems for sales table inside all of these schemas. And as per the object naming conventions, we have created all of these objects. Now, I just want you to give one interview questions and answer for this. When a panel asks, walk me through your table design strategy. So what are you going to tell? We use transient table in the raw and staging because we can reload from S3 or rerun from raw. So paying for fail-safe storage on intermediate data is pure overhead. Curated and MART are permanent because business logic is applied and analysts depend on them. We need at least 90 days of time travel for audit and 7 days fail-safe as a DR insurance, disaster recovery. Every object follows a layer specific prefix. So show object is self-documenting without needing a data catalog. This is a complete cost aware senior answer. Okay. So when they ask you about your uh, table design strategy, you're going to explain them all of this. So that is it for today. See you in the next episode. So further episode we are going to uh, depend very less on the theoretical. I'm going to directly jump into practical things. So we are going to build it. I think I have covered enough theory now. Okay. See you in the next episode.